Hi guys, we are back with another video. That is, we are going to discuss the 2019, right? So the 2019 A-level essay paper, right? So we are going to discuss the essay paper. So guys, if you have not yet covered the uh, structured discussion, so you'll have to go through the structured discussion first. So like we have discussed the thermal conductivity using Searle's method, and then thereafter we have separately discussed the spectrometer experiment as well, right? So you'll have to go through that, and then thereafter you can move on to the essay discussion of the 2019 A-level paper, right? And also the MCQ discussion of 2019 have been posted already. So if you have not yet covered that, make sure to cover it as well. Okay, so let's get started with the essay question, guys, right? So if you see the essay, all right, so it's like yeah, I know obviously if you are seeing this question for the first time, like if you are seeing this, like you might feel like, okay, this is going to be somewhat of a difficult question because the diagrams and the passages that is given seems to be somewhat complicating, right? So actually yes, I agree with that fact that the diagrams and then the passages might seem scary, but to be honest, right, so there's nothing in the questions asked, right? I mean, like, if you see the questions that they have asked, it's simple, very simple answers are supposed to be written, right? You can solve this question in a very small amount of time, right? So actually, so therefore, like in mechanics, whenever they give you kind of scary questions with diagrams and then passages, remember one thing well, that the questions that they are going to ask is in that case going to be somewhat easier, right? So this is a similar instance, so you will see, right? So right, okay, so let us discuss the essay, guys. The first one is the mechanics essay, right? So the essay question from the mechanics, mostly this is going to be based on Newton's laws and then rotational and then those stuff, right? Okay, they are saying in electrical power generators, the frequency depends on the number of magnetic poles P. It depends on number of magnetic poles P and the revolutions per minute N, right? The frequency F is given by F is equal to P into N over 120. A portable generator has two magnetic poles, right? So therefore in that case, what is P? P is going to be what? So guys, here P is going to be 2, isn't it? Because like they are saying there are two magnetic poles. Typically works at a revolution per minute, RPM, right? So this is revolutions per minute. So which means N is what? N is 3000 rotations or revolutions per minute. All right. So what they're asking is find the frequency of the output voltage of the generator. They're asking us to find the frequency. So simply, this is the first question, right? First question, actually it is the A part, right? A part, first question. A part, first question. So the equation is F is equal to P into N over 120, right? So what is P? They have told there are two magnetic poles, and then the rotations or revolutions per minute is 3000, right? So that is divided by 120. If you simplify this, you are going to get something around 50 hertz, right? There's nothing to do in that question, right? So yeah, so that is how the questions are going to be, right? So no worries. Okay, then thereafter, so that is completed, right? Let's just move on to the second problem. The rotational speed of the generator in radians per second. We need the rotational speed in radians per second. So what is the parameter that we have to find here? What do you think? Radians per meter per second is given by omega, right? Actually, actually we can find uh, simply we can find the speed of revolutions in two parameters. One is rotations, the rate of speed, that is rotations per second or per minute or something, and then like the omega, right? So here what they have asked is the omega. Radians per second means the omega. So how would you find omega? So yeah, How would we find omega? What do you think? Simply, omega can be found by using the equation omega is equal to 2 pi f, right? Omega is equal to 2 pi f. There is an equation, right? So in rotational motions, how do we get this equation? So omega is equal to 2 pi over t, right? 1 over t is f. So therefore, f. So how do we find omega? Actually, 2 pi, 2 into pi here is, they have asked us to take it as 3, and f is 50. In that case, it's going to be 300 radians per second. So the answer is 300 radians per second. All right. Okay. Let us move on to the next problem. That is B part. In the B part, guys, they're saying they have given a longer passage and then a diagram and all, but what they're asking is very simple, right? So I'll just read out. We can pause it and then read the question properly and then proceed. They're saying a student has decided a model of hydro power plant by replacing the engine of the portable generator mentioned in A above. So with a turbine that can be rotated by a water flow, right? Okay, all right, okay. They have designed this like ascending water flow, and in order to control the output frequency, uh, like they are using this device. That is, this device is a controlling device, right? So like you do not have to exactly understand what happens here and all, right? So like simply you can see this is rotating, like, so if you see the arrangement in this rod, right? So this is rotating. While this is rotating, right? Sorry. So guys, when this part rotates, right? This spring goes somewhat down, right? So like you have seen a car jack, right? Car jacks like these, right? So you rotate the car jack, then of course it either moves up or down, right? So when you rotate the car jack, it either moves down or up. So that is the same mechanism, right? So here, when you rotate it, this is moving downwards in this direction. When you rotate it in this direction, it's moving downwards. In that case, this is also going to move downwards, right? So therefore the throttle valve is controlled, right? So you can control the water flow and all, right? Okay, so I guess you can take some time and read it clearly. I'm not gonna waste time on the on reading it, so that because like you actually do not need a lot of facts out of the passage, right? You just can simply answer by just reading the question in this case, right? So not always, right? So do not assume it to be the case in all the questions, right? But this of course is of course simply by reading the questions you can get to the answer, right? Draw the free body force diagram for a fly ball, assuming each arm connected to it is under tension. Consider the mass of the fly ball to be m, right? So this is B part question number 1, right? B part question number 1. Okay, this is the fly ball. So what's the fly ball, guys? If you see the fly ball, this is the fly ball, right? They are asking the actually you can see this is the fly ball. It has a weight mg, right? And they are saying it's going to have a tension T1. So this is simply it, right? This is simply the free body diagram of the fly ball. But let us draw it, right? It doesn't matter. It's like this. So there's two rods. And there's two rods. Okay. So right. So guys, I drew a proper diagram for that. Actually, the weight of the fly ball is going to be acting downwards. That is simple mg. They have given the mass to be as m, And then, okay, when you consider a rod, in a rod, like you need to be, and you need to understand that in a rod, you can either, either a thrust or else a tension can act in a rod. But here specifically, they have told that in this rod, of course, what's going to act is the tension. So therefore, since this is two different rods, we will have to assume, okay, T1 and T2, right? T1 and T2. And so the same angle, theta, theta, all right? Fine. So that is going to be the free body diagram, right? Free body diagram. Fine. Okay. Let's move on. Let's assume the next problem is if the angular velocity of each fly ball about the rotational axle is omega, if the angular speed of each fly ball above the rotational axle is omega, show that the tension in the upper and the lower, okay, the tension in the upper and the lower T1 and T2 are this. So we have to prove that the tension in the upper and the lower are this. This is the question, right? Actually, this is the question here. So I feel this is the better part in this question, right? So you need to find T1 and T2. So they are saying this is rotating with an angular speed omega around the rotational speed. And then they have also told that here L is the length of each arm and H is the height to each fly ball from the lower clamp. So what is the lower clamp? Right. Okay. From the lower clamp, right? From the lower clamp, the height to each fly ball, which means from the clamps, the height is H. So this is H, this is H, this is L, this is L. Okay, good. Now of course, since this is rotating, whenever you see a rotational motion this is actually circulating around this center, I guess, right? So if this is circulating, so you know there, like we can, whenever you deal with a circular motion problem, guys, right? So remember to apply F equals ma towards the center and the vertical equilibrium. If you do that, definitely you should get the answer. If you do not get the answer, that means there is a problem in the question. All right. So you need to understand that. So whatever the circular motion problem that is given, most of the time, 95% of the time, you will have to apply F equals ma towards the center and vertical equilibrium. So the same thing I'm going to do here as well. So I'm going to apply F equals ma towards center, right? So what is the force towards the center? T1 cos theta and T2 cos theta. This and this force, right? T1 sin theta and T1 cos theta. T1 sin theta plus T2, sorry, both are cos theta, right? Both are cos theta. T1 cos theta, T2 cos theta is equal to m. What is the mass of the flywheel? M. What is the acceleration towards the center? It is the centripetal acceleration, right? What is this? This is the centripetal acceleration, right? Right. So now how do we write the centripetal acceleration? We have three equations. Either we can use omega squared r, or else we can use v omega, or else we can use v squared over r. This, you need to consider this as r, the radius, right? Now guys, the thing is, like, here they have given omega. So therefore, I think it is better to go with this equation for the centripetal acceleration. So therefore, I'm going to use that T1 cos theta. I'll take, okay. So since T1 cos theta is common to both, I'm going to write T1 plus T2 cos theta is equal to m. Instead of AR, I'm going to write omega squared r. This is the first equation, right? And then thereafter, what else I'm going to do? So, okay, F equals ma towards the center is applied. Next what? Next, I'm going to consider the equilibrium, the vertical equilibrium. So, what is the vertical forces? Okay, T1 sin theta and T2 sin theta. T1 sin theta upwards, T2 sin theta, and mg downwards. So, in an equilibrium, the upward force should be equal to the downward force. T1 sin theta should be equal to mg plus T2 sin theta. T1 sin theta should be equal to mg plus t2 sine theta. So take this to the other side. T1 minus T2 sine theta is equal to what is it? mg, right? So now what we are going to do is now I'm gonna do a small thing, guys. So in the first equation I'm gonna do a very small simplification further. In the first equation I'm gonna do a small simplification further. Now this r I do not know, right? R I do not know. Do I know r? No, but I can write r how? R is equal to this L cos theta, because this is 90, right? L cos theta. I can write r as L cos theta. L cos theta. When you write it in that way, what happens is, see, you will see T1 plus T2 cos theta is equal to m omega squared. R is L cos theta. So if you see, cos theta to cos theta cancels out. So what remains is T1 plus T2 is equal to m omega squared L. This is the first equation. A dash, 1 dash. Right? Right, okay. Now I'm going to further simplify T1, the second equation. T1 minus T2 sine theta is what? I can easily write sine theta. Sine theta is opposite over adjacent. Opposite over adjacent. If this is theta, right? This is on the opposite side. This is the adjacent side. Opposite over adjacent, right? So sine theta is what exactly? Opposite is h, adjacent is L, right? H over L. It is h over L, mg 2 dash. So what I'm going to do is, in order to find, so okay, now I have two equations, 1 dash and 2 dash, and I have two unknowns, T1 and T2. Now I can find whatever I need, right? So when I add 1 dash and 2 dash, I'm going to get this T2 to T2 cancels out. I'm going to get T1, the answer for T1, right? The answer for T1 I could get, it will simply be, when I add them together, the answer for T1 is going to be something around, I'm not going to simplify that, guys, so you can simplify it on your own. A basic simplification, ml over 2 omega square plus g over h. The same thing, if I subtract, right? If I subtract 1 dash by 2 dash, I'm going to get T2. You can do this and see that simplification, right? So if I subtract that, I'm going to get ml over 2 omega squared plus g over h, right? So these are the two answers that we are going to get, right? Sorry, it's going to be minus here. Sorry. It's simply minus, right? When you subtract, sorry, here it's minus. It's going to be minus here. Okay, cool. Now this is the two answers for T1 and T2, the same answer that is mentioned here, right? So I have got this and this for the upper and the lower arms, the tensions of the upper and the lower arms, right? The next, what do they say? Then the next, let's go to the next problem. Actually, the second one was the challenging part, right? So apart from that, of course, the rest of the stuff are quite, it's quite easy. Let's see the third one. When the frequency of the output voltage is 50 hertz, the value of H is 30 centimeters, right? The output frequency is 50, value of H is 30. Show that the contribution to the tension of G over H term can be neglected. G over H term can be neglected. Now, what is the tension? Tension is, for example, we take the third question, right? Tension, we got ml over 2 omega squared plus or minus G over H. Like if it is the upper tension, it is plus. If it is the lower tension, it's minus, right? So G, they have given the H value, right? The height, they have given it to be as simply something around 30 centimeters, which means height is going to be 0.3 meters, right? and then thereafter they have also given the frequency as 50. When the frequency is 50, what was omega? So if you see the first problem, when the frequency was 50, what was the angular speed? 300 hertz. 300 hertz. So the omega here is going to be 300 hertz, right? So if you get the square of the omega, it's going to be 9000, right? 90,000, something around 90,000, right? So if you see this term now, T is equal to ml/2, omega squared is 90,000, plus or minus G is 10 over 0.3. So if you simplify this further, the tension, we are going to get ml/2, 90,000 plus or minus, this is 33.3. So if you compare this 90,000 value and the 33.3 value, this can be neglected, isn't it? This can be neglected, right? You can neglect this because this is a very, very large value, right? It's a larger value. So therefore you can neglect this, right? So therefore simply the G over H term, this can be neglected, right? So in that way you can say that G over H term can be neglected. So yeah, okay, fine. In that case, the third one is also done. Let's move on to the fourth one. If M is equal to 1, L is equal to 50, calculate the tension in the upper arm, right? Simply we'll have to apply the values in this, right? So M equal 1, L equal 50. M equal 1, we need to find the tension of the upper arm. Fourth one, right? Fourth question. So T1, in that case, T1 is what? ml/2 omega squared plus G over H. You know this term can be neglected, right? That term can be neglected. So T1 is simply is equal to ml/2 omega squared, right? What is M1? What is the length? They have given it to be as 50 centimeters. Let's convert it into meters. 2 omega squared is 90,000. So if you simplify this, you are going to get the tension to be something around 225,000 newtons, right? This is going to be the tension of the upper end, right? Okay, so that is also done. All right, now finally we have to discuss the fifth problem, that is when the frequency of the output voltage is 50 hertz. Okay, the contraction of the spring is 20 centimeters. Determine the spring constant. This is the spring, right? So actually this is T1, this is T1, this is T1. Actually what happens is when this rotates with omega, right? So due to this T1, due to these two T1 forces, this tends to move downwards, right? Then of course it will start to contract by a x distance. That x distance is given to be as 20 centimeters. Contract. This is the spring, right? This is the spring. So when this rotates, you know, a tension is going to arise on the upper limbs. So on this part, there's going to be two tensions acting. Due to the resultant of those two tensions, there's a downward resultant force, which means it's going to contract in the downward direction. I'll draw a very clear diagram for that, right? So the fifth one, right? So it's like this. Okay, there is something like this, and then there is a tension spring, guys, right? And then on this spring there's two tensions, T1, right? This is going to be theta, this is going to be theta, right? We know that if this is theta, this was it, right? If this was theta, this is theta. All right, okay, cool. Now we need to find the downward resultant force. Downward force. What is the resultant downward force? T1 sine theta plus T1, both these cases, right? T1 sine theta. So if you add them up, it's going to be 2T1 sine theta, right? R is equal to what is T1? 22500. Sine theta is what? Sine theta, we already know. That is H over L. Sine theta is H over L. Sine theta is H over L. H over L. Okay, so R is in that case going to be 2 into 22500. What is H? H they have given as 30 centimeters, 10 to the minus 2. L they have given as 50 centimeters. So yeah, if you simplify this, you are going to get a downward resultant force of some value, right? So I'm not going to simplify that. Now, according to Hooke's law, guys, this downward, the force acting on the spring is directly proportional to the contraction or the extension or the contraction, right? So further, you can remove this and write kx. This k is the spring constant, right? R is what now? 2 into 22500 into 30 into 10 to the power minus 2 over 50 into 10 to the power minus 2 into k. What is the contraction due to this resultant downward force? They have given it to be as 20 centimeters, right? If you simplify this, you're going to get k value something around 1.35 into 10 to the power 5 newtons per meter. This is going to be the k value, right? So hope you understood that part. All right, so let us move on to the C part. So okay, let us discuss the C part. So here they are saying when the frequency of the output voltage is 50%, the throttle valve is set to block 50% of the 50 hertz, like it's going to block 50% of the flow, right? So okay, that is valve is making an angle 45. All right, okay, assume that the closing of the throttle valve is proportional to okay. Yeah, okay, you'll have to read these things, of course, right? Let's see the first problem. According to the design, when the frequency of the output voltage becomes 25 hertz, the throttle valve is fully opened. When the output frequency is 25 hertz, the throttle valve is fully open. The valve will remain fully open even for frequencies lower than 25 hertz. Determine the following at the instance of fully opening throttle valve. Like when this is fully opened, we need to see what the tension is. Simply when the output voltage is 25 hertz, we need to see what the tension is, right? So how would we do that? Simply we need to first of all so simply what we need to find is when the frequency is 25 hertz, what's the tension of the upper arm. When the frequency is 25 hertz, we need to check what the angular speed is, right? So what will be the angular speed? Actually, when the frequency was 50 hertz, right? So when the frequency was 50 hertz, the angular speed was 300 hertz. So when the frequency is kind of halved, then the angular velocity will also become halved, right? Simply you can figure that out, right? So if you divide this by 2, the answer that you get is also going to be divided by 2, 150 radians per second, right? So like simply, right? So or else you can find that as well, right? So it's no big issue, right? So the first one in C part is new omega is 2 pi f, 2 into 3 into f is what, 25 hertz. So this is going to be 150 radians per second. Now we need to find the tension of the upper arm. T1 is going to be what? M what is it going to be? M L over 2 omega squared G over H, but this is negligible, they have told. So therefore T1 is going to be, what is the mass? 1 kilogram. Length of the arm is 50 centimeters. 2 omega squared is in that case 150 squared. That will be something around 5,625 Newton. 5,625 newtons, right? So this is going to be the value. Okay, fine, we have found that. What else now? And that is okay. Now we need to find next the contraction of the spring when the output voltage is 25 hertz. We need to find the contraction of the spring. This is a good question, guys, right? So you need to be very clear on this. Now when the omega is 300, when the omega is 300 means when the frequency is 50 hertz, when the frequency is 50 hertz, right? What happened was, what did happen? When the frequency was 50 hertz, the height they have told this has 30, this has 30. What is this? This is the spring, isn't it? This is the spring, right? So is it in the natural length? No, not yet, because they have told that if this is first the sleeve, right, it has compressed by how much? They have told when the frequency is 50 hertz, when the frequency is 50 hertz, when the frequency of the output voltage is 50 hertz, the valve of H is 30 centimeters. Okay. And then also they have told when the frequency is 50, the spring is contracted by 20 centimeters, which means the spring is contracted by 30 centimeters. So what should be the natural length of the spring? What should be the natural length of the spring? 30 plus 30. Okay, this is 20, right? So they have given it to be as 20. I have taken it as, sorry, my bad. This is 20. 30 plus 30 plus 20. This is 80 centimeters. So therefore the natural length is 80 centimeters. So simply when the frequency is 50 hertz, natural length was what? That was 80 centimeters. So now when the frequency becomes 25 hertz, the force decreases, right? So when the frequency was 50 hertz, so you saw the tension was the force was, this was, the tension was 225,000, this value. But when the frequency decreased, the tension has decreased, isn't it? The tension has decreased, right? So therefore what happens is, initially it might have been somewhere here contracted, right? And then due to the decrease of the frequency, due to the decrease of this tension forces, right? Due to the decrease of the tension forces, the resultant force acting on the spring decreases. When it decreases, what happens? This reaches to somewhere here, right? Now the new contraction is, let's assume E. Now the new contraction is E. The new tension is what? 5625. This is for 225000. 5625. All right. So fine. Okay, this is E. Now what is the length? Now what is the length of the spring? This was what? 80. This was 80. So therefore this new length would be what? The new length would be 80 minus E. 80 minus E. 80 minus E. The new length is 80 minus E, right? So, right, okay, it's like this now, all right? Now it's like this. So the new height is what? This H dash, right? So H dash, 2H dash is equal to what then? 80 minus E. And H means what? H means this height. Let me show you this height, right? H was, when the frequency was 50, H was 30, right? So when the frequency decreases, this sleeve slightly goes up, right? So therefore the H changes now. H changes. Now it is H dash. So H dash, 2H dash is going to be 80 minus E. This is the length of the spring now. All right. Length of the spring. Okay. All right. Now what? Now we have the length of the like H dash. So that is, we can find H dash. H dash is equal to 80 minus E over 2. 80 minus E over 2, right? So actually there's two forces acting, right? There's two forces acting, T1, T1. So therefore this is going to be what? This is theta. This is theta we already analyzed. So the force acting on the spring is 2T sine theta. The force acting on the spring is 2T1 sine theta is equal to KL. KL. All right. Sorry, it's KX, right? KX. KX means the extension, KE, the extension. How much it has extended by this one. I extension is contraction here. So 2 T1 is, what is it, T1? 5625 sine theta. How do we write? Sine theta, we write it as opposite over the length, H over L, H dash over L. KE 2 into 5625. H dash, we can write it how exactly? H dash, we can write it as 80 or 80 minus E over 2. 80 minus E over 2 divided by length, 50 centimeters. The length of the arm is 50 centimeters. K is 1.35 into 10 to the power 5 into E. So if you simplify E is going to be 6.15 centimeters, right? So E is going to be 6.15 centimeters. That is the contraction of the spring. This is somewhat of a good question, right? So this question is very important, right? So try to go through that 2-3 times, right? So it's a good question. Like everything links what we have done previously, right? Okay. Let us go for the final question of the C part. When the frequency of the output increases, the throttle valve closes gradually to decrease the flow rate. If the flow rate is blocked by 75%, what should be the frequency of the voltage? Now they are saying when the frequency of the output voltage is 50%, it is 50% is blocked. 50% of the flow is blocked. So you know that